Okay, that's good. Hello, good morning all. I'm going to give a talk about SSH doing it right. I will cover these topics. I will give you a small introduction in different protocols. I don't know your knowledge level, so it might be easy for you if I start from the beginning. Why do you want to use SSH? What is SSH? Don't be confused with other protocols. So just a summary on the different protocols. I will also give you a small introduction in PKI, public key infrastructure. I have to do this because I want to talk about public and private keys and certificates. And in order to follow that, I have to explain a little bit about PKI. And then I will give you some introduction in some more technical things on SSH, some tips and tricks. And lastly, there is a Q&A session. I have to warn you though, I think the first part of the session is for a broad public. The second part of the session is more technical. Could be boring. I don't mind if you play with your laptop or want to leave the room or sleep, it's also fine. So why do we have to give a talk about SSH? I think because the neighbors do it better, so we can do it better as well. I am Wouter Dazeleer. I'm an operations engineer at Nucleus. I'm in a small DevOps team, working hard on very cool technology. I think I'm a tech geek. I love technology. I'm a gadget freak. And I'm a proud father of 2 little boys. So what I want to know is, who are you? Are there developers here? So I think most developers are operations people. 2, 3, 4. And are there people who tell developers or operations what they have to do? So managers? 1. 1 lucky bastard. To prove I'm a tech geek, I made this presentation not in PowerPoint and not in Keynote, but I made it in ShowOff, another framework. I invite you to browse to this IP address, it's my PC, and then you can follow along with the slides. You can play forward, backwards, or you can follow with me. It's easier if you want to see the commands in progress. Let me give you a minute. Does that work? Yeah. Okay, perfect. So, as I told you, I will give you a small introduction of different protocols. I don't know, again, your knowledge level, so I think we have SSH, and then 3 different types of FTP. I guess you all know FTP and secure copy. Who knows SSH? Who uses it? Great, perfect. So it's a little bit not necessary to explain it. So yeah, FTP, I guess you all use it. Do you know the difference between, who knows the difference between FTPS and SFTP? Perfect. So I will explain it. So you have FTP, it's a plain text file type protocol, to file transfer protocol, to move files, change ownership, change permissions. But it's clear text, so everyone can see your password and can see the data you're sending, if they're able to do a man-in-the-middle attack. To stop that, you can use FTPS or SFTP. They look the same, but they are completely different. FTPS is built on top of SSL. You can compare it one-on-one like HTTP and HTTPS. Uses exactly the same technology there. X509 certificate. SFTP, it's also secure, but this time it uses SSH. First it builds an SSH tunnel, and on top of that SSH tunnel it uses FTP. So it's almost the same, but it's using SSH, and this one is using SSL. And then lastly, you have secure copy. What's secure copy? It's like copying a file on your local machine from one place to another, but this time remotely. And it doesn't have a lot of features. It just copies the file from one place to another place. For example, you cannot modify the ownership, you cannot change permissions, you cannot change the modification dates. It just copies from one to another place. So today I want to talk about SSH and why you want to use it and what do you want to do with it. But first I have to give you an introduction in the cryptography. Do you all know, who knows the story of Bob and Alice? Okay, perfect. Who's Bob, who's Alice? Maybe there are strange names, but we could also say it's person A or person B. Or the cryptography world likes to describe it as Alice and Bob. And this time Alice wants to write a love letter to Bob. So Alice is on the left, of course, and Bob on the right. So she puts her love letter inside an envelope and mails it to Bob. The problem is the mailman who delivers the message is able to open the letter and read the love letter of Alice. It's like FTP. You can clearly see what's going on if you're able to look inside the message. To solve that, we arrange a meeting and we exchange physical keys. Let me first put up a story and then come back to the real world. So we arrange a meeting and they bought a box with 2 keys, 2 physical keys. Now they go back to each other, to their own rooms, and if Alice wants to write a love letter to Bob, she writes it, puts it in the box, and locks it with the physical key she received from the meeting. This time the mailman, what he sees is a closed box. He cannot open the box because he doesn't have the key. He can throw the box away, so Bob did not receive the love letter. That's basically what he can do. So if Bob receives the package, he uses the same physical key as the one from Alice, and he's able to open the box and read the love letter. So that communication was secured. But there's a problem. In the internet, it's quite difficult to arrange a physical meeting and exchange keys. Would not be so practical. So that's where asymmetric keys come into play. Who knows asymmetric keys, the difference between asymmetric and symmetric? Okay, a couple of people. So this time, the same story, but Bob buys a padlock in hang slot. A padlock with 2 keys, with 1 key, sorry. And this time he sends the padlock to Alice. Alice puts her love letter inside the same box and locks it with a padlock. Clack, it's closed, you cannot open it anymore. Also important to note is once Alice puts the love letter in the box and closes it, she's not able to open it again. This time it goes over the mailman again. Same story as before. Mailman is able to see the box but cannot open it. And now Bob, who has the key of the padlock, is able to open the box and uses the key to open the box. So what did we do? We also had an encrypted session. It was not able to look inside, the mailman was not able to look inside the box, and we did not exchange physical keys. That was because we had 2 parts, the padlock and the key opening the padlock. In the real world, it would be called a public key and a private key. The public key is like the padlock. You can send it to anyone, and anyone who uses it can encrypt something with it, but not decrypt something with it. It's only the private part of the key who's able to decrypt the same message. So what happens in the real world? It's some boring text, so I will switch back to here. Bob puts his padlock, he sends his padlock to Alice. Alice generates a symmetric key, so let's say a password, encrypts that password with the padlock from Bob, sends the encrypted message to Bob. Bob is able to decrypt the message with his private key, and once he does that, he knows the password that Alice has generated. So further communication will be encrypted with the password, not with the private public key part. So once we established a cipher and a ciphertext, we use the ciphertext to encrypt furthermore. But there's a problem, here, a small difference between symmetrical, asymmetrical, just to highlight. Symmetrical encryption is fast, while asymmetrical is slower, especially on embedded hardware. It's resource intensive. It uses a lot more math than symmetrical keys, and therefore it's not suitable for big messages, while symmetric keys are suitable for big and small messages. But there is a problem. The problem is, how can I be sure, I'm Alice, how can I be sure that I received a padlock from Bob and not from a hacker or someone who's trying to impersonate Bob? We don't know. The same applies if Bob receives the message from Alice again. How can Bob be sure that it was from Alice? We're not sure. That's why certificates were invented. And certificates and cryptography, it's a little bit complex, but let me put it like this. I'm here, I'm Wouter, and DrupalCamp knows I'm Wouter. I guess if I ask your question, if I ask your name, that DrupalCamp can confirm that you are you. So we both trust DrupalCamp, and if I doubt, I ask DrupalCamp, and DrupalCamp will tell me, yes, indeed, that's Wouter, or yes, indeed, that's Bob, and that's Alice. So we use a third party here who verifies the identity of the person. In fact, that's only what a certificate is. It's a stamp telling, yes, this is the person who he pretends to be. That's the part about that. We can have two certificates in the real world. We can have server certificates and client certificates. Server certificates, you all know, it's used in SSL. It's used, for example, if you go to PayPal or to Gmail. The certificate presented by Gmail or PayPal is verified by a third party. Your browser does the work by verifying it's indeed from a third party who says who he claims to be. So your browser trusts that is indeed connected with PayPal. So that identifies the server, hence a server certificate. The same applies for client certificates, but most clients will authenticate with a username or a password, or if you have a better system with two-factor authentication, so with a SMS code or a code generated by your phone or another method. But client certificates are also used, but not that much. For example, your Belgium identity card, it's using a client certificate to log on Taxon Web and identify you as a person. They don't use a password, no, they use a certificate. Who's the third party in case of the government? It's the government itself. I think that's enough about certificates and cryptography. So let's talk about SSH again. One thing about SSH, I hope you all use SSH keys. Who uses SSH keys? Oh, perfect. I don't have to explain this then. Yeah, it's obvious why you have to use SSH keys. It's more convenient, it's more secure, it's not prone to brute force attacks. You can have a manager for managing your SSH keys. So that's the reason why, of course, you have to use SSH keys. Here's a slide explaining how to generate a key pair, but because you all use it, you already know this. So it generates a public and a private key pair. What you then do is you copy the public key pair on the server, and with your private key pair you can log in. There are two methods for doing this. The manual one, it's the one on top. It's just using some Linux commands to copy over the key to authorized key fast. On Linux you also have a binary for this, SSH copy ID. And once you have done that, you can directly SSH to your server without requesting a password. You're logged in. Now what's in for you as a Drupal user, but because you already use SSH, I want to give you a small demo on Drush. Who knows Drush? Oh, perfect. Also everyone who uses Drush remotely? Okay, also almost everyone. So this one is how to use Drush remotely over SSH. On a Mac we install Drush. And we create a config file, and this config file contains an alias called dev. It's our dev environment. In this case, it's the dev environment of Reggae and I'm able to use this alias when I want to use Drush. So let me give you a small demo. Oh, sorry, I think I locked my PC. So what I'm doing here is I'm calling Drush, I'm calling the alias @dev, and I'm asking the car status of Drupal. What in the background he's doing is building up an SSH tunnel. He's using my private key to authenticate, and I can use it. And because you all know Drush, it's not that impressive anymore, I think, but let me... I particularly like this one. If I need access to the database, I just can type CLI, SQL CLI, and I have access to the environment I want to. Also, if I want to have SSH access, especially if you have different servers, different environments, you can do it like this, and you have a prompt on your server. So that was a really small demo. Then some more advanced topics. This is the part where I think it gets boring. So again, I don't mind if you want to do something else. The problem is, if your users are logging in, especially if you have a team with a lot of developers or even external parties, I guess you want to audit your users. You want to follow them, what they do, what they didn't do. And there are a couple of techniques. I will explain them. But first you have to ask the question, why? Because we have a history file on a Linux, and a history file contains already audit data. It contains the last commands used. But there are a lot of pitfalls with the default history file. For example, by default the history file is read-write by the user who uses it. So he's able to open the file and remove some clutter or some malicious things he was doing or some things he didn't want you to see. So that's not good. That's one thing. Wait one moment because my slides are not following here. Okay. Another thing a user can do is he can not only alter the file, but he can also change the behavior how the history file works. For example, he can change the history file to def null, which is put it in the bin, and then there's no history file anymore. And then also an important thing to note is the first one. A history file is only written once you log out. That means if you have a long-running SSH session, there is still no history file written to disk. It's still in memory in the SSH session, and it's only written to disk once the user logs out. It's really important because it also is not written to disk if your SSH connection breaks, for example. So if you close your laptop and you were logged in, you go home, you open your laptop again, the SSH session was closed, no history file, so no recording. But we can do a couple of tweaks to get it better. Who knows Chatter? No one? Perfect. It's so on Linux you have 3 different. Sorry? Okay. On Linux you have 3 different file permissions. You have owner, group, and others. That's not enough, and most file systems provide extra attributes you can set on files. For example, you can say you can modify this file but not delete it. Or you can, even if you are root, you're not able to delete this file. I used this technique 10 years ago for my MP3 collection. If I did something stupid and I did rm-rf star, my music was not deleted because I marked it as I cannot delete this one. And even the root user cannot delete it. So what we do here, the most important files, for example the first one, the history file, we put it in a mode append only. That means you can add things to the file, but you cannot remove things which were already in the file. And the same is true for our bash profile and our login files and all kind of files bash uses to build up its profile. Why do we do that? Because we put some logic in the history file in the next slides, and we don't want them to be altered by the user. So this makes it append only. Then this one, how does bash know where to write its history file, how many commands it needs to write in the history file? It's all set in environment variables, mainly most of these ones. And by adding this to your profile, you can see it's pretty obviously, you make them read only. So if you, as an admin, say, this file, the history file is this file, the user is not able to change it anymore. The second one is to fix what I just told you about the history file only be written to disk once you log out. Every time a prompt is shown, the prompt command is run. And what this does is flushes the history to the file. So every time you have a prompt, it is written to the history file. So that's the history file, but there's a problem with it. We fixed already a couple of things, but what if you have multiple servers, multiple users? How do you audit that? Because every user has his own history file, so it's pretty much impractical to audit your users by auditing their history file. We can use syslog for that. We can use syslog by extending the prompt command I just explained to write the history file to disk. We can extend it with a script which will not only write it to the history file but also echoes it to your syslog for every user. So if you have 10 users on one server, all the commands the user has run will be written to syslog. Still, there are some problems with this technique, because if the user switches to a super user session using sudo, we lose track of this one. And also, the user, if he spawns a new bash and uses another profile file, so normally it's etc profile or the one found in your home directory, if he specifies another profile file, he will be able to circumvent this. And you will see in the history file that the user has started a new bash session, and that's all you can see, so you lose track. For that reason, you can use the syslog option built into bash. This one is a very good technique to catch all the commands run. There's only one problem. There's not a single distribution who compiles bash with this option. So if you want to use syslog built into bash, you have to download, in case of CentOS or RPM distros, the source RPM, modify the source, build your own package, maintain it, put it on a repo. It's a little bit of a hassle for something which I think should be configurable as an admin. And then again, there's a last option, but I did not mention this in the slide because it would be too big. You can also use a tool called audit. And with the tool called audit, you can audit whatever you want, basically. You can monitor files, you can monitor actions the user has run, and this one understands syslog and it can also be used, but it's a little bit difficult to set up right. So, but what if you have a user, let's say an external party, and you only want to grant them a subset of commands? So, of course, this user doesn't have sudo access in this case, because you don't want to give him sudo access. You also want to restrict the commands. To do that, we can use a little script. This one is an example one. If the external party just wants to see the processes running on your server, he uses PS. If you want to stop Node.js, for example, or Apache, you can add it here, or start Node.js, you can do it like this. And how can we force this now? Because this is a little script, a wrapper, and it will deny all other actions. Well, your authorized key files has support for a forced command. It's the one on top, command equals, and then that's our wrapper script. That means if the user logs in, this command is run. The command the user has typed in will be in the variable SSH original command. So we can use that to test what the user is trying to do and only allow certain actions. Then what about server certificates? Since you all use SSH, you're pretty familiar with this screen. If you log into a new server, it will prompt you for, hey, I'm a new server, do you want to accept my key? And you have to say yes or no. Everyone says yes, of course, because otherwise you cannot log in. But there's a problem with that. First, how do you know that you're really connecting to your server the first time? You're not. It's the same as with Alice and Bob. She's not sure that the package was from Bob. So everyone says yes, but what if it was me, as a man in the middle? You would not notice. And also, if you rebuild a server, or changes the IP address or regenerate the keys, you will receive a warning like this. Who has seen this screen? Okay, perfect. There are two things people always do. The first one is remove the known host file, or if they look closely, they can also remove it from the known host files, its location. But again, what if I'm the hacker trying to impersonate your server? He will always accept. So it's pretty easy to fool you on this way. So that's not good. We're going to use server certificates for that one. What we do is we take the public key from our server. It's in fact this one presented here. We take that one and we sign it with a key that only we have. And this signed public key, it's called a certificate. We install this certificate on every Linux host we have. If we then use SSH, we're able to say, verify the public key of the server if it's signed with this key. So that means if you log into a server who has a signed certificate, your SSH client will just accept and will not prompt you with this one. If your server is rebuilt or the key is changed or the IP address is changed, it doesn't matter because we verify if the key is signed by the trusted party. In this case it is, so we will never see this message again. So I would all advise to use server certificates, because if you see this one coming up and you're using server certificates, you're damn sure there's something wrong. There's someone messing with you. Then we can also do the same for client certificates. So in the previous example, you saw me using the authorized key file for adding the user its public key to the authorized key file. That's good, but what if you have to do that for 10 servers and 100 users per server? There are 1,000 files you have to manage. It becomes really impractical. Of course, today you have tools like Chef or Puppet or whatever tool you want to use. But still, if you don't use these tools, it's quite difficult to manage that. In that case, I would do the same as with server certificates. So instead of adding the user his public key to the authorized key file, we use another key, preferably another key than we used for the server certificates, and we sign our user keys with this kind of key. And on our server, we say in the authorized key file, this one in the this time in the global one, not in the one installed on the user its directory. We tell them to verify if the user who tries to sign in is indeed signed with this key. So it's the same, but the other way around. The advantage is that you only have to install one key on every server, and every user can log in on every server which has the key installed. A nice advantage of using SSH keys is that you also can, SSH certificates, is that you also can limit the time on the key validity. For example, if you add a user to the authorized key files on the system you already know, it's forever and ever until the key is removed from the authorized key file. Again, if you have an external party and you want to grant them access to your server, you can create a certificate which is only valid, for example, for 2 hours. Then he can use his key to log in on the server, and after 2 hours, you as an admin don't have to do anything. The key will be rejected. So that was my talk about keys and certificates. Who uses JumpHosts or knows what JumpHosts are? Who knows who JumpHosts are? What they are? Okay, perfect. Imagine this scenario. So you as a developer on your PC, you want to connect to host A, but you want to also connect to host X, Y, or Z. These hosts are behind host A, or are firewalled, for example. So only host A is reachable from the internet. Who has seen this scenario? Okay, a couple of people. To fix this, you can use a jump host. There are a couple of ways to tackle this one. I'm going to talk about 3 options. The first one is an SSH port forward. Who knows SSH port forwarding and tunneling? Perfect. The second one is an SSH agent. Who uses an agent? Okay, perfect. And the proxy command. Who knows the proxy command? No one. Perfect. So the SSH tunneling, what we actually will do is we log into host A and we create a tunnel, a port forward as you would like, from this machine, so from my local machine over the SSH tunnel towards host X. So the first command, it says create a tunnel, listen on localhost port 2222, connect this one to host X on port 22. That means if you do a telnet on your local machine on port 2222, it in the end will be connected to host X in this example. So that means that you this time can log in to localhost on this port. And in fact you're logged in to host X. So the one behind host A. This works perfect, but it has some drawbacks. For example, if you now want to SSH to host Y or Z, you have to repeat this process. You have to add an extra tunnel, an extra port forward to allow you to access Y or Z. I think this one works. Most people know this one, but it's not practical, especially if you want to copy files from, let's say you want to copy a file from your machine to host X. In the example I just gave you, you have to copy the file first to host A, SSH to host A, and copy the file further from host A to host Z. It's not so practical. So the second one is using an SSH agent. The SSH agent works like this. You have your key pair, your SSH key pair, and it will be added to a manager. A manager who's able to manage all your keys and export your keys using what they call a Unix socket over an SSH connection. So that means what you can do is you can SSH to host A and directly SSH from host A to host Z, for example, while the key in fact only lives on your machine. Host A is able to use the key on your machine because you're using SSH agent. This works. I used this technique a couple of years. The problem with this technique, it's not secure. Anyone with root access on that machine is able to steal all your keys, or use your keys at least. Not steal them, but use them. So that means that if a user is logged in and I am root, I can impersonate being the user who logged in. Don't use this option. I tell you right now, if you want to use it, make sure on Linux you give this option. What this option does, the -C, it will prompt you on your graphical interface that someone is trying to use your key over the SSH agent. If you use it for your own purpose and you log into host A, and from host A to host Z, you will get a prompt notifying, hey, host A wants to access your key. Is that okay? Yes or no? So if someone tries to steal it, it will not work. This is an example on a host, on an SSH agent. So the SSH agent is on most distributions already running, as well as on Mac. So what you do is you do SSH add, and it will add your key to the SSH agent. You can use SSH add -L to see if the key was added correctly. And this time you say SSH capital A to host A. What that means is export your SSH agent to host A, and from then on you're connected on host A, and you can connect to host X directly from host A. Again, this works, but don't use this technique. Use this technique, the proxy command. It's a lot easier. I don't know if you know, but your local machine, if you're using SSH, can have a config file. This config file can contain a lot of options about each host. For example, if you want to have aliases on your machines, so instead of using that long server names or different to remember IP addresses, you can create aliases just by adding them to the host line, as seen here. So what we do here is we add host A to our config. We configure it to use a certain username and put in a certain IP address. And we also configure host X and do the same. We configure a user and a host name, a port if the port was different than 22, but in our case it's 22. And then the magical one is the proxy command. What the proxy command does, as you can see, it will spawn an SSH session to host A in the background and opens a netcat. Who knows netcat? Okay, netcat is just a TCP connection, an easy to create TCP connection between two machines. So what it will do, it will open a TCP connection to host X using host A. That means you can type in SSH host X and you're connected to host X. The rest was happening in the background. You did not even notice that you were connecting to host A. It also means you can now copy files from your local machine directly to host X. That's basically it. And then here are some hardening tips on SSH. Default distribution is fine, but I like to point out these different things in the config file, which I try to use. The client alive interval of 300 seconds means that a user is logged out if there was no activity for 5 minutes. Why do you want to do this? Because we all know it's Friday evening, you want to go home after a day of work, you still have some sessions open, and the sessions will be open until Monday. To force that the connections are closed, server side, we say the alive interval. Then this one, I think most distributions do it already correctly. I've seen recently a distribution, I don't remember the name where it's not set. What this will do is, there's no reason to remotely log in as root user. There is not a reason to. You're a user and you can use sudo, and that's fine with it. But don't use the root user, especially because there are a lot of script kiddies and botnets who try to brute force your user. If you deny the ability to log in, they can try as long as they want. They will not get access. And this one is a little bit, let me say, controversial. By default, SSH runs on port 22. By changing it to another port, you rule out most script kiddies and botnets. And then the last two is if you have a server with multiple interfaces, try to pin your SSH session to a certain IP address. I think this is all, and I would like to ask if there are questions. No questions? Yes?
Proxy command you showed, had two parameters. What are those parameters? The H and P, I think it was. Okay, sorry.
Okay.
I couldn't make it out.
Okay, no problem. I should have explained that one. Other questions? Yes?
You mentioned the wrapper SSH, and how do you provide a sign? I saw a sign right after the wrapper SSH, and how do you provide this signing?
So your question is how to use the signing technique. I will give you, I hope I have internet here.
Slide where you can see in the authorized key
the forced command, you mean?
Yes.
This one?
Yes, and there is no port forwarding, and there is a sign.
Ah, okay. Okay. Let me explain it, what it actually does. So this one forces the user to run the wrapper, and the wrapper will verify the command that I explained.
Nice.
Then the no port forwarding and the no X11 forwarding are added as extra security. Because if you enable that one, there are a lot of things you can do by creating an SSH tunnel and break out the wrapper script. So it limits the user on using port forwards. And also no X11 forward. Who knows? You can use X11 over SSH. Okay. So the graphical interface of a Unix or Linux, you can also run it remotely, but put a screen on your local PC, and it's called X forwarding. We also disable this one. Because if you could enable X11 forwarding, there's also a technique to break out that one and circumvent the wrapper script. The no PTI is actually also an extra security measure added. It will deny an interactive prompt to the user. So you have to specify the command, and the command will be verified by the wrapper script, and there's no easy way to circumvent around this rule. Did that answer your question?
Actually, my question was how can I make probably this is a fingerprint or something like that.
You mean the whole string here? Okay. It's the one that came from here. So in the first place you generated an SSH key pair, public-private key. And then you copied, let's take the top example. We did a cut of the public key pair and we added to the authorized key files. Did you ever seen a public key pair? No? Okay, because it looks like, where is it? This.
Yes, exactly.
So this is the public part of the key.
So it's okay. I thought that this is some fingerprint
No.
wrapper SSH.
No, it has nothing to do with
my public
on a normal.
key. Okay.
Let me try to show you. So on a normal authorized key file,
Yes.
this would be
Exactly.
in the key file. So we added some options before the key explaining what this key is able to do. So you can also see that you can set options per key.
Now it's clear.
Okay, perfect. Other questions?
Some hosting companies are implying that you need to create a key larger than 4K. I don't know what your take on that. Did you experience a hack on smaller keys? Has it been breached?
No, but it's...
Using period, I think, but...
What I still do is I use, it's a good question, I use for my signing keys a key of more than 4,000 bits, but for my user keys I still use keys lower than that one.
And then RSA or DSA or whatever?
Actually it doesn't matter, I use RSA most.
Every year there's a blog post of some university that breached, but the way they breach, it never happens with pure computability. It's
No, indeed.
toying around with electricity or something external.
Just never use a key of 1024 bits,
Yeah.
because that one is, it's most these keys which they can break. But it's always a race against time. Ask me the question 10 years ago and I would say 10,024 would be enough. So I understand why hosting providers are willing to use 4K bits. Other question? Perfect.
Thank you very much.
Okay, thank you.